Okay, so once you've got a mesh, you're going to want to add a mesh variable. Mesh variable, all it does is add a data point onto each vertex of the mesh. It can be a scalar data point, it can be a vector if you want to represent a velocity field, so a scalar might be a temperature or a pressure. And the point about mesh variables is they also act as a field in the sense that you can ask your mesh variable for a value at anywhere, any position, arbitrary position in the domain, and via the interpolation functions it will give you a result based on the neighbouring nodes. In parallel, its decomposition will just follow that of the mesh. Everything in parallel, all objects just follow the decomposition of the mesh. Okay, so make a mesh variable, very straightforward. Mesh, use mesh variable constructor. Once again, Shift tab inside the parenthesis, see the options. It asks us for a mesh. What mesh is the mesh variable going to live on? And a degree of freedom count, so vector or scalar, or it can be an arbitrary number. We can also pass in a data type, and you can use any data type you like as long as it's a double. So you can only use doubles. Right, so let's reuse a previous figure, so we can just append a new drawing object onto that previous figure. Use objects dot surface. Now, when you're using a surface object, it wants to know what mesh it's going to draw a surface over. So you have to pass in mesh as the first argument, which is the object we just created, and also what function. We're going to come to function soon, but the mesh variable is itself a function. All right. And then we can do fig show. Not much to see. We haven't set anything on it yet, so it's just 0. Right, so I mentioned we've exposed our data as NumPy arrays. So the way you access that is via the data handle on the object. Now, various objects have data handles on them that allow you to access whatever data relates to that object. So, for instance, we have our mesh variable, and we use .data. We have a look at it, it says 0. If you want to set values on it, grab an index, and let's say 10. Let's set this to 1, 2, 3, 4. Right, now let's have a look at that now. We should be able to see that. Right, there's the value we just set in that position. Once again, I'll just remind you that you can grab that question mark to actually get a detailed documentation about that object. Also, we've usually got various examples in that documentation as well, so keep that in mind. Just about the indexing of these arrays themselves. So I did mention, have a look at the shape here. So we've got mesh data. It's a NumPy object, so any NumPy methods or attributes are valid. Shape. So this is 289 by 1. So basically it's one just long array. And the point I'm trying to make here is that while it's a Cartesian mesh, we'll always index it as a 1D array. So let's have a look for index in range 0 to, let's grab mesh bar data shape.
So the indexing follows the Python-C number, C row-wise.
Yeah, I'll draw a picture now for you. Let's see, index. I'm just going to set the actual mesh variable data to be the actual index of that object itself. Right. Mesh does not support JavaScript. Right, I need to add that guy there. Now let's have another look. Right, so your numbering starts at the bottom left, walks across, and then up. And actually what we can do, let me just jump back a couple here. Actually, we'll continue as is. Let's actually, okay, just going to clear that figure. Fig.append. In fact, what I'll do, we'll see. So with the mesh viewer, you can ask it to actually render the actual numbers of each node. There's a bit of a bug on mine, which we'll see how it goes with that, but let's just take a look. Right, okay, so this Death Star thing in the corner, I have no idea what that's about, but it's just a bug on my current visualization setup. I think for you guys running the Dockers, you shouldn't see that anyway, but we can see the numbering here, and it goes 0 through to 16, 17 through to 33, etc. One thing to keep in mind is that in parallel, so the numbers, when we ask for the node numbers here in the visualization engine, it actually returns global identifiers for those nodes. So those numbers will be, it's a unique identifier across the entire parallel simulation. Typically, these arrays that the arrays you're only going to deal with are local arrays. So you will typically have a local chunk of the domain, which might be like, if it's 4 procs, it's probably like this corner here, and the numbering is going to run from 0 to, in this case, it'll be 10, but then here it will be 11 through to 20 or whatever. The point is that you're always going to be indexing using local index starters, not the global index of that mesh or vertice. So, I mean, the index itself is rarely particularly useful in of itself. In that, it doesn't matter. It's, you're normally interested in some physical quantity or a physical position. So the index is rather just incidental detail. So what we often want to do is walk through the mesh vertices themselves, find the location of that vertice, and then use that location data to set the attribute on the corresponding mesh variable itself. So I'll point out that the mesh has a data handle on it that we'll use now. So what we can do is use this pattern here, and this is a pattern that we use a lot. So we do for index and right, so this is the pattern we're going to use. Probably the only real difficulty here is this enumerate function. This is just a native Python function. What it does is you hand enumerate a list of objects, and what it does is it returns 2 things. It returns the index of the object and then the object itself. So in this case, it's going to return the index and then the vertice of the mesh. So we'll do that, mesh.data. All right. Just to make that clear, let's just do that. All right, 0, then the coordinate 1, the coordinate of the vertice, etc. So let's, what shall we do here? Let's import the Python math object, and then let's go mesh. And we're going to set the value on the index it's returning, and then we'll do something like, let's say, math.sign of pi times vertex, and let's grab the vertical axis of that. Let's make it 4 point times. That's not right. I've forgotten this data guy again. There we go. So we've just done something basic here. We've just grabbed the vertical axis of the vertical coordinates of the mesh vertices and used that to use a basic trigonometric function to define our mesh variable. So, I mean, obviously, if you want to do that in the horizontal axis instead, you just switch that. And so forth. Obviously, we'll get to a point where the mesh resolution is going to start to struggle, aliasing effects and whatnot. Okay, so at some stage you're going to want to deform your mesh for whatever reason. So let's have a look at that. Okay, let's create a new mesh. Okay, so if you don't pass in any parameters, it's going to just use the default parameters. All right, and you can see the default, again, if you hit Shift-Enter, default element type, default resolution is just 4x4, and it's just basically a 4x4 resolution unit square. Very straightforward. Right, so again, I mentioned the mesh has a data handle which we can use to modify it. So let's grab the first vertice and let's just try and set it to something. Let's say 0.1. Now this won't work. Okay, because the mesh vertice data is read-only. All right, so how do we do it? We need to use this deform mesh context manager. All right, so the idea of the context manager is that it forces you to do any mesh modifications in a block, right? And that allows us to run various things at the start of the block before the deformation and various things at the end of the block. So it might be sanity checks to make sure your mesh is still a reasonable mesh, and also we'll update various metrics relating to that mesh, like the element sizes or the globe or the domain size. That's why we force you to do all mesh deformations inside the deform mesh context manager. So the way to use it is with a with statement. So you go with and then grab your mesh object and then you use the deform mesh method on that object. All right, and then you start doing whatever modifications you want to do within that indented block. Let's just try and do exactly what we just did. One. All right, job done. Now,
what does this do behind the scenes? Does that create like a block that at the end you run a cleanup function?
Yeah, basically, yeah. So at the end, we want to update various metrics. I think it's mainly metrics we're looking at relating to the mesh, like like the global size of that mesh if it's modified, or the element sizes if the elements are now smaller because you've modified them. And also when we have swarms, we're using swarms. Also, we need to do things like if there's particles that are no longer inside the mesh, they need to get thrown out or whatever we want to do with them. But those objects also need to be made aware that the mesh has been modified. So it's our way of forcing you to, and the alternate would be to not force this, but then you guys having to remember, oh, I've modified the mesh, so now I need to call some other function that signifies that I modified the mesh. But this way is safer because we just force that.
But I mean, I think I just don't understand the syntax. If I put it up so it creates a block that in essence it runs a constructor and a destructor of an object.
Yep.
The constructor enables you to do a destructor at the end. Just clean up work.
That's exactly it.
I think that's exactly how to read it, and I don't know why they chose to read it as the keyword.
Yeah. But I mean, that's basically it. It just allows us to run something before this block. So I mean, the block, obviously, whatever you want to have in here. But so at the start of this block, before all of this is executed, we might run something, and then after all of that is executed, behind the scenes, something might be running there. Right. So let's make a new figure quickly. Have a look at that one. Alright, so we've moved the mesh corner here. This line is the bounding box. We can get rid of that actually. What is edge color? So again, just tab, start typing, tab to find your options here. I couldn't remember exactly what it was called. Let's just make that white so it goes away. Well, it's actually gone away and drawn white over the top edge. So let's go ahead and go yellow, for instance.